Hi guys, welcome to my first ever environmental science lecture. Um, Hopefully this will be easier than trying to take notes in class. You can stop, pause it whenever you need to if you need to catch up writing or whatever. Hopefully it'll just be easier for everybody. So the first chapter of environmental science is about understanding ecology. So first of all, environmental science, the study of interactions and relationships among living things and the things around them. So it might be physical things in their environment, like a tree or a pond, or it might be chemical interactions, like plants using photosynthesis to make food. Um, my slide won't go there. Okay, so ecology. Again, dealing with living things and their environments. So ecology is based on observation, what we see around us, and objective interpretation of data that we collect. So, not your opinion or how you think things should be. And ecology is practiced by ecologists. Seems pretty common sense, right? People that study these interactions in the environment. So, a little bit different idea here, an ecologist versus an environmentalist. Environmentalism is based on emotions, beliefs, what that person thinks is important as opposed to what is actually happening. So, an environmentalist is someone that's politically active in some way that's interested in the environment. So, those are the people you see having like rallies on the side of the road against driving your cars or polluting the ocean or whatever it is. All right, organization. This section is pretty much a review from biology, so I'm going to skim through it really fast. How do ecologists organize living things? So, an organism, the individual plant, animal, fungus, bacteria, whatever. Oh, population, a group of similar organisms. So, maybe all the squirrels in Kingsley. A community, all the populations living in an area. So, all the people and all the squirrels and all the grass and all the robins and all the cats living in Kingsley. Oh, my slide doesn't want to go again. An ecosystem. So, yeah, a community and its environment. So, all the living things living in Kingsley and the water and the soil, and the buildings and the roads, the signposts, all the things that we interact with. And then the biosphere, all of the ecosystems on Earth, everywhere that life exists. So from as high in the atmosphere as there's anything living, and then as down far into the soil as there's anything living. Also called the ecosphere. This we went over in biology also. Within the biosphere, things are divided into. They leave kingdoms out of this one. I'm not quite sure why, but phylum, class, order, family, genus, and then species is the most specific. We're not going to worry about that too much in here. Shared resources. They use the term all pretty loosely here. Yes, the majority of all organisms share a lot of the same resources, but there are some organisms that don't live in sunlight, so we can't say all. There are some organisms that don't live in soil, but for the most part, the majority of all organisms share the sun and the soil and the water, the air, things like that. All organisms have to meet their energy needs. So, again, very straightforward explanation. Not exactly 100% right, but pretty darn close. Plants get nutrients from the soil and then use sunlight to make that into food that they can use and that other organisms can use when they eat them. Human impacts. If you haven't caught on to this yet from looking through the book, a lot of environmental science is based on how human activities affect the environment. Erosion is something you live in Iowa, you probably hear about quite a bit. It's kind of a big deal, especially if you live in an agricultural community. Not to say that agriculture is the only source of erosion, but it's one that's talked about a lot. If you're a farmer, you don't want to lose your soil. You want to keep that soil there so you can keep using it. So you'll have good soil to grow your crops in the future. Pollution, obviously, that's a big deal. Humans create a lot of different pollution to the air, the water, the soil. Industrial and solid waste, pesticides, petroleum, acid rain. I don't know if they're including like acid snow in there. They want to call it acid precipitation, but anything falling out of the sky with acid in it. I would just go with acid rain. My slide doesn't want to go again. I think my computer's dying. There. Okay, erosion. Wind and water will naturally move soil. That's always going to happen. It's impossible to completely stop it, but we have increased that quite a bit. Anything we do to clear land, not leave what was originally there, it's probably going to speed up the rate of erosion. Too much erosion could contaminate the water. If you've got a slow moving river, it could just stop flowing if there's enough erosion clogging it up. Obviously, it's not great for the soil. If you take our nice Iowa black topsoil and wash it all down the river, that doesn't leave us much to farm with. Pollution, a harmful material making contact with a life-sustaining resource. So getting something in our water, in our soil, in our air that's not supposed to be there. All right, so forms of pollution, industrial waste. Everything produces some sort of waste. You can't always blame it on manufacturing or mining or agriculture or people living in cities. We all produce waste. That's just a fact of life. Could include metals, chemicals, acids, fertilizers, oil, antifreeze, etc. Solid waste. So all that stuff that the garbage man takes every week. Sometimes it's sent to landfill and buried. Sometimes it's burned. Sometimes it's recycled. Just depends on what it is and what waste collection service you have. In landfills, if they're just going to leave it there to break down, it takes a long time, a lot of times longer than they expect. Sometimes landfills aren't designed the best, and they start leaking something into the ground that isn't supposed to be there. Obviously, we burn our garbage. Depending on what the garbage is, that could be a big problem for the air. Pesticides, chemicals used to control some sort of pests. If you've taken one of my ag classes, you probably already know that the name kind of tells you what it controls. Insecticides control insects. Herbicides control plants. Rodenticides are used for rodents. Fungicides are for fungus. Obviously, we use a lot of pesticides every year. Look around you. If you live in Iowa, you're going to see pesticides. Not only in our cornfield out in the parking lot, but in town. There's pesticides all over. You see those little flags, people getting their yards sprayed all the time. Petroleum. I think we all know petroleum is an oily, flammable liquid, right? Usually find it underground. We use it for lots of stuff. Mainly, we think about gas and diesel. And obviously, it's not good for the environment. The EPA has a lot of regulations on petroleum being released in the environment. Pretty much any time I did any fueling operations with the Army, if it was in the U.S., if we spilled a drop on the ground, you'd have to dig a hole It was a lot of work. I think it was if it was more than 2 gallons, we had to call the EPA, and you had to dig this huge hole and collect all the soil, and they had to come out and inspect it and make sure you cleaned it up right. In Iraq, that wasn't so much of a big deal. At times, we had massive fuel spills and just let it soak back into the ground because that's where it came from, and the EPA wasn't in Iraq to make us clean it up. Um, Big environmental disaster involving oil. The Exxon Valdez, this was when I was a kid, I remember it. So there's this big oil tanker. The captain was apparently pretty stressed out, got drunk, went to bed. The guy that was in charge after that, he didn't catch on to where he was, ran into this big reef. There was supposed to be a radar system to detect the reef. It had been broken for like a year, and the people that owned this ship didn't want to spend the money to fix it. So they hit this reef, leaked 11 million gallons of oil into the water. It was a bad deal. Did a lot of damage to the organisms living there. So it was a pretty big deal. It was the biggest oil tanker spill up until probably about 50, no, probably almost 20 years ago now. The Brightwater Horizon one. Maybe some of you will get that for your presentation that you're going to do pretty soon. Poster, not presentation, sorry. Acid precipitation. I don't know why they can't just call it acid rain, whatever. Car exhaust, burning waste, sometimes from factories. Things are going to combine with the air, and anything that's in the air is eventually going to come back down. At some point, it's going to connect with some water vapor and come down as rain. If your rain has acid in it, that's usually a bad thing. Can damage organisms, water supplies. There was like a water tower or something in New York that was being eaten away by the acid rain. Conserving resources. So this is the end of this chapter. What should we do about natural resources? Obviously, everybody has a different opinion, just based on what you believe, what you value. There are some people that think we should just completely not allow any human use of certain sections of land. That's why we have national parks. And then conservationists, people that want to use the natural resources but not damage them. And then, of course, there's people that just don't care and they're going to do whatever they want and not worry about how it affects the environment or our natural resources. So there's a pretty wide spectrum there. And that, I believe, is the end of chapter 1.